All right, we're going to do the back of the study guide for your test tomorrow. Here we go. Coach Harris begins the season with 72 football players on his team. After some intense practices and conditioning, he begins to lose 3 players each week. A. Write an equation for the total number of football players F. Coach Harris will have after W weeks. Okay, so he starts with 72 players and he loses 3 per week. And then that will tell you how many total football players he has. So F will be at the end. Okay, how many players will be left on the team after 5 weeks? So we now want to plug in 5 for the W that I used here because it was 72 minus losing 3 per week. So you start out with 72. He loses 3 per week, and this says they're 5 weeks. So 3 times 5 would be 15. So he starts with 72. He loses 15 a week. So then he ends up with, let's see, 72 minus 15 would give me 57. Okay, and then here, how long will it take for Coach Harris to lose all of his football players? So if he starts with 72, he loses 3 per week. We want to know how many weeks it will take for his total number of football players to be 0. Okay, here we go. We're going to solve this equation, inverse of adding or subtracting. So I'm going to subtract 72 from both sides. Bring down a negative 3W equals a negative 72. Divide both sides by a negative 3. And we end up getting a 24 weeks. Okay, let's come up here for this problem. Okay, we have not done ones just like this, and it says if 2x plus 10 equals 32, give true statements involving x. We have the same thing going on we had in the last video at one part. So let me try to cover the other stuff, and so I could just hopefully focus on that. Doesn't really want to. Okay, so for this particular problem, you are just going to do the inverse. I don't know why this is not wanting to focus. I apologize. We're going to do the inverse of this, and we're going to do 2x plus 10 equals 32. Subtract 10 from both sides, and you get 2x equals 22. Divide both sides by 2, and you get x equals 11. So some true statements are, if you subtract the 10 from both sides, you would end up getting 2x equals 22. That's a true statement. If you solve the problem, you would get x equals 11. That's a true statement. So it's just kind of steps in your process. Okay, let's look down at the next part. And this is over the, is it one a solution, infinite, or no? Okay, you solve them exactly like we solved the other ones. Don't means you see if there's distributive, no. Call, combine like terms. So over here, we can combine those two. So that gives me x plus 7. Over here, we can combine those two. So I get x plus 7. Guys, look, we already have the same thing on both sides. If you have the same things on both sides, then it is infinite, and you're done. Okay, let's look at number 13. On problem 13, don't call me after midnight. The first thing that we're going to do here is we're going to do the distributive. So we need to multiply what is on in front times everything in the parentheses. So you do that first. So I have 2x plus 4 plus 3x equals 2x plus 2 to plus 1. Okay, don't call me. That means to move, I'm sorry, don't call is to, the C is to combine like terms on either side. So I can combine these, and that gives me 5x, and then the plus 4. And then over here I can combine those two. Those are like terms because they don't have a variable. All right, and the next thing then is don't call me. So we're going to move variables to the same side. So I'm going to subtract 2x from this side and from this side. So I have 3x plus 4 equals 3. All right, and the next step would be to, I feel like I have missed something here. So let me see if I have 2x. Oh, that's right. Okay, and so now I'm going to do inverse operation, and I'm going to subtract 4 from both sides. And so on this side, I'm left with 3x, and on this side, I'm left with a negative 1. So I'm going to divide both sides by 3, and my answer ends up being x is equal to a negative 1/3. So that means I do have a solution here. Okay, let's work on number 14. Oops, lost it. Where'd you go? There you are. Okay, here we go. First step, distributive. Well, we don't need to do the distributive here. So instead we're going to combine like terms, step 2. So I'm going to combine my 4x and my positive 2x. And that gives me 6x. I'm going to bring everything else down. Well, I have different variables, so I know I'm going to end up getting one solution. So here we go. Okay, we didn't have the distributive. Call, we combine like terms. Me, move all of the variables to the same side. So that's positive, so I'm going to do the inverse and subtract 2x from both sides. And this gives me 4x minus 1 equals 1. Now I'm going to do the inverse of adding or subtracting. I'm going to add 1 onto both sides. And so this gives me 4x, and this gives me 2. Last step, I'm going to divide both sides by 4. And that gives me x equals 2/4, which of course simplifies down to 1/2. So this one also had one solution. Okay, let's look at number 15. Here we go. First step, don't call. So call means we're going to do the distributive. So here we go. We are going to distribute this 2. So that gives me a negative 3x minus 3 plus 5x minus 1 equals 2x minus 4. Over here now, I'm going to combine like terms because that's the next step. So I'm going to combine a negative 3x plus 5x, so that's 2x. And then I'm going to combine a negative 3 minus 1, and that gives me a negative 4. And then I'm going to bring this down. And so this is the same thing on both sides, so this is also infinite. All right, let's go down to the bottom part, and then we'll be done after this section. Okay, in this section, these are literal equations, and we're going to isolate the variable. And for this, we're going to always solve for the y. We want to isolate the y. We want to get it by itself. So in this equation for number 16, I want to get this y by itself. So to get that y by itself, I need to move what's with it. So to remove, let's see if I get this to stop. Having a hard time here. Okay, so I want to get the y by itself, so I've got to move what's over there with it. So I need to move that x. So to move that x, it's positive, so I'm going to subtract x from this side and from this side. So that cancels, and I do have y all by itself. Now, for this part, I can either do 8 minus x, or I could do y equals a negative x plus 8. Either way is fine as long as you have a positive 8 and a negative x. Okay, I'm going to move to some notebook paper because that's driving me crazy. So I'm sure it is y'all too trying to watch. Okay, I'm going to go over to problem number 17. And 17 is 3xy equals 12. Okay, once again, I want the y by itself. That's what I'm trying to solve for here. So if I want this y by itself and I'm multiplying, then I'm going to do the inverse and divide by the 3 and the x. So y is by itself. If I divide that side by 3x, I have to divide this side by 3x. So I end up getting 12 over 3x. Well, look guys, I can simplify that because 12 divided by 3 will give me 4 on the top, but then I still have an x on the bottom. So I would have y equals 4 over x. That would be your simplified answer. Okay, let's look at problem 18. All right, 18 is 2x plus 3y equals 18. Once again, the whole point is to get that y by itself. So I'm going to do the inverse of adding or subtracting. So I'm going to move this positive 2x. So I'm going to subtract it from this side and from this side. So that gives me 3y equals, you can put either one of these first. I'm just going to put this one first. It was a minus, so I made it a negative. That's a positive 18, so I put plus 18. The last step to get y by itself is to divide by 3. And if I divide that side by 3, I have to divide everything over here by 3. So when I do that over here, I have y. Now I want you to look. 3 will divide into 18 evenly because 18 divided by 3 is 6. So you could actually just put a negative 2/3 with an x there plus 6 and leave them the negative 2x on top, 3 under it, and then just divide that part out. Okay, let's go over and do number 19. Okay, for number 19, it's the same type of problem. We have 2x minus 3y equals 21. Okay, so here we go. We're going to do the same thing. We want to get y all by itself. So I'm going to move the 2x first. So I'm going to subtract 2x from both sides, and I'm going to bring everything else down. This is multiplication, so instead I'm going to divide everything by a negative 3. So I get y equals, here a negative over a negative gives me this, but then over here 21 divided by a negative 3 gives me a negative 7. So that is my final answer there. Okay, almost done. 2 more problems. Number 20. Here we go. 20 has a equals x y squared 2. This is a lot like the area equals pi r squared. We want to solve for y. So I want to get y by itself over here. So first I'm going to move the x. So I'm going to divide by x because that's multiplication. If you divide this side by x, you have to over here too. So that gives me a over x is equal to y squared. Well, I don't want y squared. I just want y. So the inverse of squaring would be to find the square root of both sides. So the answer is square root of ax equals y. That is your final answer. Okay, and the last problem, problem number 21, is as follows. Here we go. Volume equals 1/3 xy. I want y by itself. So first, I'm going to divide by x because I'm going to get rid of that x. So I'm going to divide both sides by x. So over here, I have v over x. Then I have equal to 1/3 y. Okay, I want to get rid of 1/3 on this side. This is multiplication. The inverse of multiplication is to divide. When you divide by a fraction, you want to multiply by its reciprocal. So I'm going to multiply both sides by 3 over 1. This cancels, and this cancels where I just have a y on this side, and over here I have 3v over x, and that is my answer. Good luck on your test. Study back over these for further help.